Hello everyone, I'm Rahul Shandilya, and in this lecture of Internet of Things we will discuss network function virtualization. In the previous lecture we have seen a software defined network, that is another virtualization concept that we have used in our network infrastructure that helps to make it more scalable, manageable and flexible. So in SDN, what we have done is to separate the data flow level with the control logical level and data flow level. The data flow level is implemented in the physical plane, that is physical devices, or what we have said data device, the flow devices. And in the logical part, that is the control plane, is implemented in software which is located in the cloud. So basically, this separation brings flexibility, manageability, and scalability, and also it helps us to add many services, extra services based on the interface provided by, say, the control plane, that is the northbound API. So, network function virtualization, that comprises two words, basically network function and virtualization. So, basically, we are all aware of what virtualization means. Now, what is here network function? Network function means the basic functionality that we have to use to send data from source to destination, like firewall, NAT translations, deep packet inspection. So these functions are very important, and these are traditional network implemented in some physical devices. They are basically custom devices, custom switches. Now, if we virtualize these in function based on the concept of, say, container or virtual machine, we can again have better scalability and maneuverability. So this is a different approach for utilizing the virtualization concept to make it more scalable and flexible. And again, this network function virtualizations, and remember, SDN are not, though they have a different way, they are not say opposed to each other. They can be made compatible, as we will see in basically in next lecture. So what is basically virtualization? A variety of technology for managing computer resource by providing an abstraction layer between software and physical hardware. So software are not tightly coupled. That is, the application software is not say tightly coupled with the hardware. These technologies effectively emulate or simulate a hardware platform such as server, storage device, or network resources in software. So virtualization turns physical resources into logical or virtual resources. Virtualization enables users, applications, and management software operating above the abstraction layer to manage and use resources without needing to be aware of physical details of the underlying resources. Virtualization technology enables a single PC or server to simultaneously run multiple operating systems or multiple sessions of a single OS. A machine running virtualization software can host numerous applications, including those that run on different operating systems on a single platform, hardware platform. The solution that enables virtualization is Hyper Machine Monitor VMM, or commonly known as hypervisor. This software sits between hardware and act as a resource broker. So basically, how virtualization helps and how it is implemented. So in traditional way, software is very tightly coupled with the physical device, physical layer, that is hardware. So we know that it is possible that the software is not utilizing your hardware efficiently or in an optimized way. So if abstraction layer is added and uh, this physical device act as a virtual, this abstraction level provide an API that physical devices act as a virtual machine, and this software can then we run multiple software to utilize this hardware basically in optimized way. So virtualization turns physical resource into logical or virtualization, and how it is done by adding an abstraction layer. And this virtualization basically is the virtual machine VMM known as hypervisor. This is also called acting as a resource broker. That basically it translate anything. Broker means it translate one data format from into another data format. So the common example is that of VMware or VirtualBox that helps us, that enables us to use a single PC, that is CPU memories, by different operating systems. So in this diagram you can see we have this layer of physical hardware, and this abstraction layer, this virtual machine manager VMM or hypervisor sits between this physical device and here virtual machines. Virtual machines hold OS of operating system. So basically on this abstraction layer we can create multiple virtual machines, and this is the concept of virtualization here. Another type of virtualization is the container virtualizations. In this approach, software known as virtualization container runs on the top of host OS kernel and provide an execution environment for application. So the virtual machine basically can have share the same physical layer, the physical devices, and can have multiple OS on the top of the virtual machine in multiple virtual machines. But in container based virtualization, the difference is that instead of saying common physical say hardware resources, physical resources, we share the common kernel, operating system kernel. So it is basically a lighter option of virtualization, and it is getting more popular because it is lighter and faster than the virtual machines. Unlike hypervisor, VM containers do not aim to emulate physical servers. Instead, all containerized applications on host share a common OS kernel. This eliminates the resources needed to run a separate OS for each application and can greatly reduce overhead. That is the added advantage of using container-based virtualization. Because the container executes on the same kernel, the sharing home most of the base OS containers are much smaller and lighter weight compared to hypervisor-based OS machines. So basically, this is another option, but here in NFV, basically we use virtual machines. So what is the motivation of NFV, that is network function virtualizers? New network services may require additional different type of hardware appliance. Finding the space and power to accommodate these boxes is become increasingly difficult. New hardware means additional capital expenditure. Once new type of hardware appliances are acquired, operators are faced with the rarity of skills necessary to design, integrate, and operate increasingly complex hardware-based appliances. Hardware-based appliances rapidly reach end of life, requiring much of the procure, design, integrate, deploy cycles. Means once every time we change, say we need another service, we have to deploy, say different kind of physical devices, and the whole cycle of procure, design, integrate, deployment has to be repeated without any revenue benefit. As the technology and service innovation accelerate to meet the demands of an increasingly network-centric IT environment, the need for increasing variety of the hardware platform inhibits the introduction of new revenue-earning network services. So basically, these are the problem with the traditional network infrastructures, and we try to sort some of these by implementing NFV, the virtualization there between the software and hardware, so that we can have a custom say services on same type of hardware. The NFV approach moves away from dependency on variety of hardware platform to the use of a small number of standardized platform types with virtualization techniques used to provide needed network functionality. So number of the physical devices, variations of physical devices has reduced. So we have less number of standardization, and the devices can be made more compatible. So NFV concept. Let's see now start. What is the concept of NFV? NFV is significant departure from traditional approach to design, deployment, and management of networking services. NFV decouples network functions. Network functions can be of various types, like network address translation, that is the NAT devices. We can have another functionality called firewall. Intrusion detections, domain and DNS services, caching, and there are multiple network functions. So NFV role is to separate, decouple these network functions from proprietary hardware appliances, so that they can run in software on VM. Because these proprietary hardware can, if we have uh, multiple hardware for multiple each say of these functions, uh, we have the problem of standardizations, interoperability. So NFB wants to decouple these network functions from this proprietary hardware, so that they can run in the virtual machines. So the various network functions devices include network function devices such as switches, routers, and access. And another one is network related compute devices such as firewalls, intrusion detection system, and network management systems. Another type of function network attached storage, file, and database service attached to the network. In traditional network, all devices are deployed on proprietary closed platforms. All network elements are in closed boxes, and hardware cannot be shared. With NFV, however, network elements are independent applications that are flexibly deployed on unified platform comprising standard servers, storage devices, and switches. In this way, software and hardware are decoupled, and capacity for each application is increased or decreased by adding or reducing virtual resources. So this is basically we can see in this figure we have multiple network functions, and these are basically now deployed in a single virtual machine VM, not a single virtual machine, in a virtual machine, and these virtual machines can be deployed on, we'll see later in NFV. So basically these virtual machines basically run on this proprietary hardware. NFV terminal. So to understand NFV, basically first we go through some important terminal and network functions. A functional block within a network infrastructure that has well-defined external interfaces and well-defined functional behavior. Typically, this is a physical network node or other physical appliance. Network services, a composition of network functions that is defined by its functional and behavior specifications. Network function virtualizations. The principle of separating network functions from hardware they run on by using virtual hardware abstraction. And then we have NFVI. This is an important term because the virtual machines stand on this NFVI architecture, infrastructure, network function virtualization infrastructure, NFVI. The totality of all hardware and software components that build up environment in which virtual network functions are deployed. The NFVI can span across several locations. As I pointed out, that this infrastructure is spanned on multiple hardware, multiple point of presence. That NFVI can span have across the network providing connectivity within these locations is considered to be part of NFVI. So the hardware uh, that stand below the NFVI layer and the connection between them together form the part of infrastructure. NFVI node, physical devices deployed and managed as a single entity, provided NFVI functions required to support the executions environment for VNF. So, physical network function (PNF), an implementation of NF via a tightly coupled software and hardware system. This is typically a proprietary system. Then we have virtual network, a topological component used to affect routing of specific characteristics informations. The virtual network is bounded by its sets of permission network interfaces. In the NFV architecture, a virtual network route information among the network interfaces of VM instances and physical network interfaces provide the necessary connectivity. Virtual network functions, an implementation of NF that can be deployed on an NFVI, NFVI POP, and POP, that is point of presence, where network function is could be deployed as an VNF, virtual network function. Networking forwarding path, ordered list of connection points, forwarding chain of NF, that is network functions, along with policies associated with the list. VNF forwarding path, virtual network function forwarding path, graph of logical links connecting VNF nodes for the purpose of describing traffic flow between the network functions. So in this, say we have this example, or single example of NFV. We can understand NFV by this, say, figure. In the first figure, that is a part, graphical representation of end-to-end network service. In traditional base, this is the traditional based network. Here, see, a packet leaves from say endpoint A and reach the destination endpoint B. So the packet has to travel through various network functions like NAT, DNS, or so on. And these network functions are basically deployed on network infrastructure, the hardware part. Even the NF part is also basically custom hardware. So this is a tightly coupled infrastructure. So what we have done in, we can implement these same NF1, NF2, NF3 using virtualizations, which is shown in, say, the lower part of the figure, that is B part. So we have separated these physical devices, the hardware resources, say hardware resources in physical locations. What we call and then is NFVI POP, that is network function virtualization infrastructure point of presence. And between this and we have created an abstraction layer also called the virtualization layer here, the red is color. And above this abstraction layer we have various network functions, virtual network functions deployed on this NFVI. So now the logical links and the packet transfer from this on this VNF to VNF. So it is very easy to control these virtual logical links rather than directly controlling these physical devices. Of course, the data itself flows through the physical devices, but the control lie here in the logical layer. NFV NFV Principles. The VNF are building blocks used to create end-to-end network services. Three key NFV principles involved in creating practical network services. The first is service chaining. VNF are modular and each VNF provides limited functionality on its own for a given traffic flow. Within a given application, the service provider steers the flow through multiple VNF to achieve the desired network functionality. This is referred to as service chain. The second is management and orchestration. Management and orchestration, that is syncing the various say NFA nodes. This involves deploying and managing life cycle of VNF instances. Example include VNF instance creation, VNF service chaining, monitoring, relocation, shutdown, and billing. Manner also include the NFV architecture, and then we have distributed architecture. A VNF may be made of one or more VNF components, VNFC, each of which implements a subset of VNF's functionality. Each VNFC may be deployed in one or multiple instances. These instances may be deployed on separate distribution hosts to provide stability. So this is the basic introduction of NFV. In the next lecture, we will discuss uh, architecture of this, frameworks and architecture of this NFV, network function virtualization.